All right, let's take a look at how we can determine both arc length and sector area in this video. We're going to start with arc length. What you see here is an example of arc length here in red, this curvature right here. It is part of our overall circle. Imagine that this circle just continues all the way around. Right? Instead of trying to find the circumference of the whole circle, we're just going to try and find this small portion of our circle, noted as arc length. Now, in order to do that, we're going to use this arc length formula, which coincidentally uses the circumference formula. If you recall, the circumference of a circle is 2 times pi times r, the radius. But now what we're going to introduce is a fraction that we're going to multiply times the circumference formula. Because arc length is just a portion of the overall circumference, and we can denote what portion of the circle we're to use based off of theta, based off of the angle we are given. So what we see here is the formula shows us that theta divided by 360, because 360 is the total number of degrees all the way around in a circle, 360 degrees. So we'll take the angle we do have, theta, divided by the total of number of degrees, and that's going to tell you what portion of the circle we're working with. If you take that and multiply it times the circumference of the circle, you will find the length of the very specific arc you are trying to find. So let's look at some examples. In this circle, what I know is that I have a radius of 4 meters, right? A radius from the center of my circle all the way out to my outside edge. I know that I have an angle of 164 degrees, which we could also denote as theta in our formula. And let's say in this example, I want to find arc C, D, and B, right? So let's say I ultimately want to know what is arc CDB. I want to know what its value is, okay? So let's take a start with our arc length formula. I'm just going to abbreviate arc length as AL. Arc length is equal to theta, which is the angle we have, divided by 360 degrees times the circumference formula, which is 2 pi r. Now, in order to solve for the arc length, we need to input the values for theta and the radius. And in this example, both of those are given to us, right? Theta is the angle that we have, 164 degrees. And the radius is given to us right here as 4 meters. So if we input both of those values into our formula, we now can find the arc length by taking 164 degrees, our angle right here, divided by 360 degrees, the total number of degrees in an entire circle, times the circumference formula of 2 pi and my radius of 4. Now, if you were to enter this into a calculator exactly as you see it, 164 divided by 360 times 2 times pi times 4, you would end up with an arc length that is equal to 11.4493, on and on and on, right? We're going to round it. We'll round to 2 decimal points to the hundredths. So the 9 will make the 4 and the hundredths round up to 5. So we could say in general that our arc length is 11.45, and then we need our units, which is meters. So arc CDB, this arc right here, is 11 and 45 hundredths, oops, not centimeters, 145 meters. Okay. Look at another example here. Again, this time, what we're going to notice is that 332 degrees, that's my angle, or theta, in our equation. And it's opening up to this arc right here, B to D, all the way around to C. This is a rather large arc here, arc BDC, okay? That's the arc that we're going to find because it's what our angle is opening up to. We have a radius here of 9 centimeters. So let's input that into our arc length formula, right? Again, arc length is equal to theta divided by 360 degrees times the circumference formula, 2 pi r. 2 times pi times your radius. What we know is theta is 332 degrees. So 332 degrees divided by 360 degrees times 2 times pi times my radius, which is 9 centimeters, so times 9. Again, if I enter all of this into my calculator, what I get out is, after rounding, 52 and 1500ths centimeters. So that is what this arc length is valued at. Not 15, what am I saying here? That's the decimal. 52 and 1500ths centimeters. Again, centimeters being my unit. So what you're probably noticing with this, right, in order to calculate this out, we need to just take what our angle is and put it in for theta. And then we need to take what our radius is and put it in for r. Once you've input those two values into your formula or your equation, you can just enter it into the calculator exactly as is. Now, similar to arc length, we have sector area, right? It's going to be a very similar formula. The difference being that in our sector area, we can go with equation here. In our sector area equation, right, instead of multiplying times circumference, now we're going to multiply times area, right? Pi r squared is the area formula for a circle, because what we're trying to do is we're trying to find the area of this slice of the circle, right? And just like in arc length, we're going to multiply the area times this ratio, or this fraction, right? Which is going to represent what portion of the entire circle do we have, right? I'm not looking to find the area of the entire circle, right? That's not what I'm looking for here. What I'm looking for is just the area of this small piece of the circle. So knowing that all the way around a circle is 360 degrees, and knowing that we have an angle in here, theta, I can create a fraction or a ratio comparing those two, multiply it times the full area of the circle to find out what just this small portion of the circle has as a value. Let's look at two examples. In this example here, I have a radius listed as 21 centimeters, right from my center straight out to my outside edge. I have an angle denoted with this box symbol, which tells me that it is 90 degrees. So I can find the area of this sector by using our sector area formula. I'll abbreviate as SA, sector area. It's going to be equal to theta, your angle, divided by 360 degrees times the area formula, pi times your radius squared. So that's the major difference between arc length and sector area, is that instead of multiplying times the circumference formula, now we're multiplying times the area formula. Just like we did before, 90 degrees is my angle, that replaces theta. 21 centimeters is my radius, that replaces r. So I'm going to rewrite my equation as 90 degrees divided by 360 degrees times pi times my radius 21 squared. And when I enter this into my calculator exactly as it is, I find a sector area equal to 346.36 centimeters squared, right? Again, I'm taking my units, centimeters, and now I'm squaring them, because what I'm finding really is an area, and any area needs units squared. But the area I found, 346 and 3600 centimeters squared, is truly this area of the shaded in region. Not the whole circle, but just this sector. Okay, so just like arc length, you need to take your angle, input it for theta, your radius, input it for r, multiply it out in a calculator, and you will get your answer to your units squared. Let's do one more example here. All right, here's what we know. We know this angle right here is 135 degrees. That'll replace theta. We know 2 represents segment BA here, which is our radius. So input that into our sector area equation. So sector area is equal to theta over 360 degrees times the area formula, pi r squared. Let's input the values we know. Theta being 135, we'll replace this. The radius being 2 inches, we'll replace this. So we can rewrite it as 135 degrees divided by 360 degrees times pi times the radius 2 squared. And just like before, we enter this into the calculator exactly as is to find out that our sector area, SA, our sector area, is going to be equal to 4 71/100 inches squared. Again, 4 71/100 after rounding, inches being our units, and squared because the A in sector area means that we're using an area formula, which means our units need to be squared.